All right, so when you took this homework home and read this article, you saw that there were some questions at the bottom. And basically the questions that are most important are what proportion of the carbon-14 present in Otzi's body when he died is still there today? Well, in the article, you saw that the proportion is 0.435 or 43.5% of the 100% that was there in the beginning. And then the question is, when did he die? Well, in order to figure that out, we'll look at a bigger graph. We would go to the graph and we would extrapolate 0.4. Well, there's 0.5, right? A half is 0.5. 0.4 is right about here. We go over. It's right about there. And then we would go down to about here. So maybe 8,000 years old. We would be guessing that that's how you would use this graph. Well, it just so happens that there's a way to calculate it. Let's go back to the graph a minute. This is a curvilinear function. It's a typical logarithmic rate of decline using a natural logarithm, which means that the rate depends upon what was there initially. And so the rate changes as the initial material decreases. But it turns out that there is a direct relationship, that is a straight line through here. If we look at the logs of the relationship between the amount of half-lives, or the proportion remaining, and the amount of time. And so it just turns out that we can solve for Otzi's age by looking at this formula. And this T, that means how old the sample is related to the log of the proportion remaining, how much remains compared to how much was there, divided by a constant, decay constant for carbon, that is 0.693, times the size of the half-life, which is 5730, right? Well, this equation uses a radioactive compound that has a half-life that's down to 35%, I'm sorry, 35%. Otzi is not at 35%, Otzi is at 43.5%. So let's do the calculations on another sheet of paper. So if we use the same equation and we substitute in 0.435 for the proportion of carbon-14 left in Otzi and multiply the data out, we find out that 6,883 years ago it was that Otzi died. And by the way, the technique is accurate to within about 10 years, because one of you asked that question earlier. Interesting, don't you think? And then another interesting fact is that carbon-14 dating doesn't work too well after 1950. Do you have any idea why?